Good morning student, welcome in our today's session. In last lecture we start to solve exercise 3.1 in complex numbers, and in that lecture we see the question number 1 and question 2. The first question I left for an exercise, so I hope all of you solve this question number first in question number 2. Now see the next question, second question, that is I into 4 into 3 plus I divided by 1 minus I. We have to express the following number in the form of a plus ib and state the values of a and b. So first we have to take product of these two, then we take division of these two complex number. I into 4, 4i plus I into 3i, 3i square divided by 1 minus I, which is equal to 4i plus 3i square, and instead of I square write minus 1. 3 into minus 1 divided by 1 minus I, since I square is equal to minus 1. Therefore, which is equal to, we get 4i, 3 into minus 1, that is minus 3 divided by 1 minus I. Now, this is in the form of z1 upon z2, division of two complex numbers. In last lecture, we see how to take the division of two complex numbers. So, rationalize this by taking complement of denominator. 1 minus I into, what is conjugate of 1 minus I? That is 1 plus I. So divide 1 plus I and multiply by 1 plus I. 4I in minus 3 into, that is 4I into 1 plus I minus 3 into 1 plus I divided by 1 minus I into 1 plus I. 4I into 1, 4I plus 4I into I, 4I square. Product कर देंगे 4 as it is, I into I square. Minus 3 into 1, 3. Minus 3I. Divided by, see here, 4I minus 3I. 1 minus I, 1 plus I. A plus B, A minus B. That is A square minus B square. Since 1 square minus I square. 4I minus 3I, I. Plus 4 into value of I square. Minus 1 minus 3 divided by 1 square is 1 minus value of I square is again minus 1 is equal to I. 4 here it is minus 4 and minus 3 divided by 1 minus 1 plus 2, which is equal to minus 7 and plus I divided by 2. First at real part, minus 4 minus 3 minus 7 and the plus I divided by 2. Therefore, this number can be written as minus 7 upon 2 plus 1 upon 2 into I. Therefore, we get A is equal to real part minus 7 by 2. B is equal to 1 by. So, this is second question. Now, see the next third question. Plus I divided by 3 minus I into 1 plus 2I is equal to. So first we have to take product of these two and then take division of two complex numbers. So write 2 plus I upon 3 into 1 plus 2I minus I into 1 plus 2I is equal to 2 plus I divided by 3, 3 into 2I, 6I, minus 1 into I, minus I, minus plus minus 2I square is equal to 2 plus I divided by, now this 3 as it is, 6I minus I plus 5I minus 2 into I square, value of I square is minus 1. That is 2 plus I upon 3 plus 5I minus minus plus 2. Therefore, it is 2 plus I divided by 3 plus 2, 5. That is 5 plus 5I. Now, we will get the complex number in the form of division. That is Z1 upon Z2. Now, again, we have to take rationalization here. 2 plus I upon 5 plus 5I into 5 minus 5I. That is 2 plus I, 2 into 5, 10 minus 10I, 2 into 5, plus 5i minus 5i square divided by a plus b, a minus b, that is a square minus b square. A is 5 minus b is 5i, that is 5i square. Is equal to 10 minus 10i plus 5i, minus 10 plus 5 minus 5i, minus 5 into I square minus 1 divided by 5 square is 25 minus, see here, 5 into I bracket square, that means 5 square and I square. So value of I square is 25 and into value of I square is minus 1. Since here and here we use value of I square. 10 minus 5i minus minus plus 5 divided by 25 minus minus plus 25. So 10 plus 5, 50 minus 5i upon 25 plus 25, that is 50. So 15 upon 50 minus 5 upon 50 into I. If we divide this, then we get 5 3s are 15 and 5 10s, and here 5 1 upon 10. So we will get the complex number in the form of where a is equal to 3 upon 10 and b is equal to minus 1 upon 10. So this is the values of a and b if our complex number is this. Now see the next question. Question number 4. 3 plus 2i write very carefully, science is very important. Question 4. 3 plus 2i divided by 2 minus 5i plus 3 minus 2i divided by 2 plus 5i. We have to simplify these two pairs of complex numbers. So first we take simply cross multiplication. A upon b plus c upon d is equal to a into d plus b into c divided by b into d. Same we take here cross multiplication. That is 3 plus 2i into 2 plus 5i. 3 into plus 3 minus 2i into 2 minus 5i. 2 minus 5i divided by a plus b, a minus b, that is a square, 2 square minus b means 5i square. Take the product. 3 into 2, 6 plus 3 into 5, 15i plus 2i into 2, 4i plus 2 into 5, 10i into I square. Here we get the product of these two brackets. Now take the product of these two. Again 3 into 2, 6. 3 into minus 15i. Next minus 4i. And here minus minus plus 5 to 10 into I square. Let us see. Divided by 2 square 4 minus 5 square 25 and I square is minus 1. Now see, opposite signs are cancelled here. See here, 15i plus and here minus 15i. Plus 4i minus 4i. Opposite signs plus and minus will get cancelled. So 6 plus 6, 12 plus 10i square, 10i square, that is 20i square. 10 into 10, that is 20i square upon 4 minus minus plus 12 plus I square is minus 1 divided by 29. 12 minus 20 upon 29. 12 minus 20, minus 8 upon 29. Here imaginary part is 0. So write this in the form of minus 29 plus 0 आहे. ज्यावेळी तुमचा कॉम्प्लेक्स नंबर प्युअरली रिअल मिळतो त्यावेळी त्या ठिकाणी इमॅजिनरी पार्ट का असणार आहे 0. If we start our complex number, in that first lecture we see what is purely real and what is purely imaginary. If the complex number is purely real, that means the imaginary number is 0 in that case. So here we will get the answer minus 8 upon 29. So we write minus 8 plus 29 upon 29 plus 0 into I. So value of A is minus 8 upon 29 and the value of imaginary part B is 0, which is absent. That means the value of this coefficient is 0. Next question number 5. 2 plus root minus 3 divided by 4 plus root minus 3. Now see, don't say this is not complex number. This is a complex number. First we have to write this 2 plus. The minus 3 can be written as 3 into minus 1 and the 4 plus again 3 into minus 1, and all of you know that the value of root minus 1 is I. So write here root 3 into I divided by 4 plus root 3 into I. First we simplify the complex number. First we write the number in the form of a plus b. Now we have to simplify this. So same divided by 4 plus root 3i. What is complex conjugate of this? That is 4 minus root 3i divided by 4 minus root 3i. Take the product again. 2 into 4, 8 minus 2 root 3i. Now multiply by 2. Now take the product of root 3i plus root 3i into 4, that is 4 root 3i minus root 3 root 3. Minus sign as it is. Root 3 into root 3, 3. I into I square. Divided by a plus b, a minus b. That is a square minus b square. 8 minus 2 root 3i and here plus 4 root 3i. 4 minus 2. Here coefficients of 4 and 2 are same. So 4 minus 2, that is 2 root 3i minus 3 into value of I square is minus 1 divided by 4 square is 16 minus root 3 square is 3 into value of I square is again minus 1. That means here 8 plus 2 root 3i and minus minus plus 3 upon 16 and minus minus plus 3. Hence it is 90. See here, real part, add the real parts. Here 8 and 3 are real, so 8 plus 3, 11 plus 2 root 3i divided by 19. So if we write this in the form of a plus ib, then we will get therefore what is values of a and b here? That is a is equal to 11 upon 19 and b is equal to 2 root 3 upon 19. So this is values of a and b. Now see the next problem, question number 6, which is very easy. 2 plus 3i into 2 minus 3i, that is a plus b into a minus b, and which is same as a square minus b square is equal to a square 2 square minus b square, that is 3 square. 2 square is 4 minus 3 square is 9 into I square. Bracket square, that means term square of both the terms. 4 minus 9 into I square, since I square is equal to minus 4 minus minus plus 9 again, which is purely real. So write this is in the form of 13 plus 0 r. Therefore a is equal to 13 and b is equal to 0. Now see the next question, question number 7. 4i raised to 8 minus 3i raised to 9 plus 3 divided by 3i raised to 11 minus 4i raised to 10 minus 2. So first you have to write this is in the form of a plus ib, then we simplify this. So first we find the powers of I raised to 8, 9, 11 and 10. In yesterday's lecture, I told you how to find the powers of r. If you have to find any power of r, then divide the number by 4. If it gets, if the number is completely divided by 4, then the answer is 1. If the remainder remains 1, then the answer is r. If remainder is 2, answer is minus 1. And if the remainder is plus 3, then the answer is minus r. So first find I raised to 8. Any power you have to find. So simply you have to divide this number by 4. So 4 2s are 8. That means your remainder is 0 since answer is 1. Next, I raised to 9. I raised to 4. 4 into 2, 8. Remainder is plus 1. That means I raised to 1 is equal to I. I raised to 10. I raised to 4. 4 2s are 8 plus 2. That is I square is equal to minus 1. And I raised to 11. I raised to 4. Again 4 2s are 8. And 8 plus 3, 11. Hence I cube is equal to minus r. If remainder is 0, answer 1. Remainder 1, answer r. Remainder 2, minus 1. And remainder 3, it is minus r. So use here. Therefore 4i raised to 8 minus 3i raised to 9 plus 3 divided by 3i raised to 11 minus 4i raised to 10 minus 2 is equal to 4 into I raised to 8, 1 minus 3 into I raised to 9 r plus 3 divided by 3 into I raised to 11 minus r. So 3 into minus I minus 3i minus I raised to 10 minus 1. So if you take here minus 1 and then it become minus minus plus 1, that is plus 4 minus 2. 4 plus 3, 7 minus 3i. 4 minus 2, 2 minus 3i. We will get the number in the form of a plus ib. Now we have to take the subtract division of these two complex number. 7 minus 3i divided by 2 minus 3i into 2 plus 3i divided by 2 plus 3i. 7 to 14 plus 7 3s are 21i minus 6i. Minus plus minus 3 into 3, 9 into I square upon a minus b, a plus b. 2 square is 4 minus 3I square. 3 square 9 and I square is minus 1. Therefore, 4i raised to 8 minus 3i raised to 9 plus 3 divided by 3i raised to 11 minus 4i raised to 10 minus 2 is equal to 14. 21 minus 6, that is plus 15. And here value of I square is minus 1. Since minus minus it becomes plus 1 plus 9. Divided by minus minus plus 9 and 4 plus 9 13. So 14 plus 9 23 plus 15i divided by 13. 23 upon 13 plus 15 upon 13 into i. Therefore a is equal to and b is equal to 15 upon 13. This is values of a and b. Now see the next question. That is question number 3. Show that minus 1 plus root 3i bracket cube is a real number. is a real number. If we simplify this bracket cube, then we get pure number, purely real number. We have to prove this. So see, all of you know the formula for a plus b cube. What is formula? A cube plus 3a square b plus 3ab square plus b cube. So here, comparing this, a is equal to minus 1 and b is equal to root 3 I, and we have to find the cube of this. So right here, root 3I cube is equal to a cube. What is a? Minus 1 plus 3 into a square. A means minus 1 square into b, root 3I plus 3a, 3 into a minus 1 into b square. What is b? Root 3I square plus b cube. B root 3I bracket cube. Minus 1 cube is always minus 1. Now see here, plus 3 into minus 1 square is plus 1. 3 into 3 root 3I plus 3 minus 1. Hence it is minus 3. Root 3 square, that is 3. Root 3 square is 3 into I square plus root 3 cube. Root 3 cube is root 3, root 3, root 3. 3 times root 3. This root 3 becomes 3. Hence 3 root 3 into I cube is equal to minus 1 plus 3 root 3I minus 3 into 3, 9. Value of I square is minus 1 plus 3 root 3, value of I cube. How to find I cube? That means I square into I. Value of I square is minus 1 into I, that is minus I. Value of I cube is minus I. Here I am writing how to find value of I cube. Minus 1 plus 3 root 3 I minus minus plus 9. 3 root 3, that is minus 3 root 3 I plus 3 root 3 I minus 3. Signs are opposite since it is cancel. Minus 1 plus 9, which is 8, and the 8 belongs to real number. Therefore, here we show that the bracket cube of the minus 1 plus root 3I is a real number. This is only, if we simplify this, then we will get only purely number, which is 8, and the number belongs to the set of real number. Now see, the next question, question number 4. Here we have to evaluate the powers of I. Evaluate the following. In exam, you have to ask the question for 1 marks. Find the powers of or evaluate the. So, if in exam you have to ask the question like this, then we have to divide by 4. That is I raised to 4. If we divide this 35 by 4, then 4 8s are 32. 4 8s are 32, and the remainder is 3. That means I raised to 4 raised to 8 into I raised to 3. And all of you know that if the remainder is 3, if remainder is 3, the answer is minus I. If remainder is 1, answer is I. If remainder is 2, minus 1, remainder 3, it is minus I. Second, I raised to 888. Divide the number by 4. 2, 2, 2. The remainder is 0. Hence answer is 1. Third, I raised to 93. Divide by 4. 4 2s are 8. 1. And 4 2s are 8. And the remainder is, here it becomes 4 2s are 8. So, it remains 1. Now it becomes 13 and 4 3s are 12. Again it is 1. So, answer is I. Remainder is 1. I raised to 1, it is I. Next, I raised to 116. 116. I raised to 4. Again 4 to the 8. Here carry 3. Again it is 4 9s are 36. 4 9s are 36. Again answer is 1. Next one. I raised to 100 and 403 is equal to I raised to 4, that is 100. 100 into 4, 400, and the remainder is 3, that is I cube, which is equal to minus I. Next, sixth one. 1 upon I raised to 58, that is 1 upon I raised to 4. 4 ones are 4, remains 1, and 4 twos are 16 plus 2, that means 1 upon I raised to 4, it become 1, and the I square, that is 1 upon minus 1, which is equal to minus 1. And the sixth one, that is I raised to 30, I raised to 40, I raised to 50, and I raised to 60. I raised to 40 plus I raised to 50 plus I raised to 60. Find 1 by 1. I raised to 30. I raised to 4. 4 7 are 28. That means remainder is 2. I square is equal to minus 1. I raised to 40. That is I raised to 4 raised to 10. So answer is 1. I raised to 50. I raised to 4. 1. Again it is 1. 4 2s are 48. Again remainder is 2. Hence I square, which is equal to minus 1, and I raised to 60. That is I raised to 4. 4 ones are 4. Again it is 2, and 4 5s are 20. Remainder is 1, since again it is 1. Therefore I raised to 30, I raised to 40 plus I raised to 50 plus I raised to 60 is equal to value of I raised to 30 minus 1 plus I raised to 40 plus 1. Again 50 minus 1, and 60 plus 1. Minus 1 plus 1, minus 1 plus 1, which is equal to 0. Since the answer of our question number 7 is 0. Now see, there is a next question, that is show that 1 plus I raised to 10, I raised to 20 and I raised to 30 is a real number. So find the value. First find I raised to 10, I raised to 20 and I raised to 30, and then take the addition of these four numbers. 1 I raised to 20, I raised to 30 and I raised to 40, and we have to prove this is a real number. If we take the addition of these four numbers, then it is purely real. That means there is no imaginary part. And the question number 6 is also very easy question. Again here we have to find the value of I raised to 49, I raised to 68, 89 and I raised to 110. So first find I raised to 49, I raised to 68, 89 and 110. Use the trick. If remainder is 1, answer I असेल. Remainder 2 minus 1. Remainder 3, don't write the explanation. Then write directly you. If remainder is 0, 1. Remainder is 1, answer I. Write directly. Then find the first values of our given powers of I, and then put the value which are find and write the answer. So homework of question number 5 and question number 6. Today's homework. Question 5 and 6 in our exercise number 3.2. I hope all of you do your homework regularly. In next lecture, we see our next questions. That is, there are only 3 questions remains, 7, 8 and 9. Thank you.